folks. I was talking about the forecasting in general and different methods of forecasting, the purposes of the forecasting in my earlier lecture. Okay, and also now we talked about several different forecasting methods that are available for for use. For the same situation. Okay, and now the next one is, if we have multiple tools or multiple procedures available to address the same situation, then which one would I go with? Okay, now which method is better? Should I go with the last value method, or averaging method, or moving average method, or exponential method, smoothing method? Which method should I go with? Okay, now to differentiate or discriminate between those methods, the tools that we can use, we use the mean absolute deviation, the error, the forecast accuracy becomes the basis. Now the forecasting accuracy becomes a basis not only to differentiate between the various forecasting methods that are available, such as these techniques that I'm talking about over here, but also once we choose a particular method, then we want to stick with it. It doesn't mean that we have got the best method for all times to come. Remember, the reality is very dynamic. What suits today may not be the appropriate one maybe day after tomorrow. Okay, in other words, once you choose a method based on forecasting accuracy, you would keep on monitoring that forecast for that forecasting accuracy, which is nothing but the error. And so what you do is, so this is the plot of the error. The best error is a 0. Then you have an upper limit, so that you obtain from statistical methods like the 3 sigma dispersion. That is upper limit. This is lower limit is maybe minus 3 sigma on the other side. So between this minus 3 sigma to 3 sigma, you get about 99.7% of all these things should lie here. Now what we want to do is, once we choose a method, once we compute the error, once we compute the error, which is defined as the difference between the actual and the forecast, that error you want to keep on plotting on this control charts. Okay, what you want to see is, you want to see a normal distribution, meaning that there is no pattern, and about 68% of the data is kind of within the 1 sigma deviation, and about 95% in 2 sigma deviation, and 99.7 in 3 sigma deviation, but without any patterns. So clearly, it should be a random distribution of the error. You should not see. But once we plot this error, we have chosen a method, and that method we are using it time after time. So on the horizontal axis is the time here. We plot the error. Then we monitor the error. But if you begin to see some patterns like this, what I have over here, what it is saying over here is, there seems to be a trend, meaning that the errors are all on the positive side. They seem to be increasing, meaning that the method that was earlier that better suited the situation no longer is a proper method. So we need to take that bias out of the forecasting method. Maybe some other forecasting method is what I need to go with. If I am with the averaging, maybe I think I need to go with the exponential smoothing. So that's that's how we monitor the forecast, and we use the forecasting accuracy to discriminate between various tools and choose the one. Once we are chosen, we keep on monitoring the errors on these control charts, or on this one. Tracking signal method is very similar to the control charts. Okay. Now, the forecasting accuracy, the discrimination the things that we use to differentiate between them is, one is mean absolute deviation, the other one is mean squared error, the last one is mean absolute percent error. So I will be showing you how to compute this for all these forecasting methods soon. But what are these? Now, I said the error as the difference between the actual and the forecast. Okay, if that is that means when my actual number is greater than the forecast, then the error is positive. What that means is that, actual demand is greater than the forecast, that's a positive error. So what happens? Since we schedule our activity based on the forecast, we basically produced less than what the actual demand is. So these are the times that when you have the stock outs, okay, which is a bad thing to have. If the actual is less than the forecast, so that means I did forecast a higher demand, like perhaps, in difficult economic times, all these retailers and all would have ordered for holiday sales the items. If the economy takes sour, they do end up with excess items that they had to sell and salvage at deep discount prices. Okay, I mean, in these difficult economic times, we do see that. So our forecast is greater than the actual. So what that means is we have leftover inventories, which is a negative error. So error being positive like stock out is not a good thing to have. Error being negative, that excess inventories, is not a good thing to have too. Okay, but so this is where we are plotting those positive and negative errors to get the trends. But when we are differentiating between the methods, we cannot look at each and individual periods and based on that decide. We want to just take a look at one number and use that number to differentiate between the various forecasting methods. So if I take the error, cumulative error, then what happens? I have positive errors, then I have negative errors, but in the end they may cancel out each other, and I may have an error of 0, which is not the case, but because when you plot, you do see a distribution, but one single number would tell you that no, you have a 0 error, means your forecast is accurate. That is not the case. So what we do is, since stock out is also bad, as is inventory, we take the absolute value of the error. That's that absolute deviation is the absolute error. So we take the average of the absolute error. Whether it's stock out or inventory, both are bad situations. Okay. Now this basically gives us that. The method that results in a least mean absolute deviation is the one that you want to choose with. Okay, mean squared error serves the same purpose. What it is over here is, you may have a bunch of small errors, both positive and negative, but there could be one big error. Okay, so that can just throw the things out of whack and make you select a wrong forecasting method. So that's where the dispersion of the error is quite important. Okay, so that's where this mean squared error plays a part. Okay, the other one is mean absolute percent error. Now, in terms of the manager's language, okay, if you say that, hey, look, I was down by 10 units. See, that's what we get in mean absolute deviation. Okay, I was down by 10 units, or I was up by 15 units. Okay, 10 units, 15 units really doesn't make that much of sense to the manager, because what you want is the reference base, 10 units, 15 units, with respect to what volumes. Is it 2% of your demand, 3% of your demand? See, that is a language that the manager speaks. Okay, so mean absolute percent error basically tells the manager that on an average you are 2% away from your mean demand. So now this tells the manager that, okay, this 2% is not is not a good thing, so I need to control mine. So when we say 20 units, 30 units, then we have to know what is the basis. What is the population that we are looking at? So, okay, that's an additional information that we need to go and then gather. See, 2 out of 1 million is better, but 2 out of 10 is bad. Okay, so now in the absolute percent error, that's what we get. 2 out of 1 million, we get a small number. 2 out of 10, a big number. So that's basically more or less the manager's language. And I want to introduce and I want to show you how you can use this MAPE. Okay, so next I will be taking a problem, then apply these various methods that we have mentioned here, but we really haven't gone into see what exactly are they. I'll explain to you each one of those methods when I work through the problems.